Hello, good evening. Good evening.
Yeah, good evening.
Good evening.
Thank
Good evening,
you.
Grandpa.
Good evening, Grandpa.
Please accept my apologies for the late start. The old man will always have technical challenge.
Our apologies
Okay.
taken.
Today, we're going to have a very brief discussion. And you know that for the macrobiology, you have some questions in bacteriology, of course, some questions in parasitology, and then in the virology session too, and then of course some little about mycology. But we've always emphasized on the bacteriology because that's where a lot of the questions come from. But you also know that the parasitology area is almost always very cheap, so that if you get even, let's say, 4 or 5 questions in parasitology, you should be able to get everything correct. So mastering your parasitology, the only defect is that you may not get too many questions from there, but even the few questions that come from there, you should be able to grasp them. And one area which you may not have to take for granted will be in the area of malaria, whether from diploma or from the degree and then the MLSC. You always have questions on malaria. So if there are few questions in parasitology, by all means, you get 1 or 2 on malaria. And so I'm sure that all of us may have covered malaria extensively from school. Just a few highlights, like, you know, this is just a review or a revision. A revision means that the impression is that you already have some knowledge, and it's just a matter of a recall of some of the important aspects. So it's not like you're going to take malaria as a topic. No, I'm just going to give you some of the highlights which you may probably miss. And I'm just filling in those gaps. For example, I'm sure that everybody, if we ask you the species of malaria, I'm sure you name 4. But now there are 5 species of malaria that infect man, or for that matter, human beings. So those are some of the small, you may, it's easy to miss that point, where, for example, they will make a statement about malaria and say which one of these is not true. And I'm sure that if they mention that there are 5 species of malaria that infect man, you may say that it is not a true statement, but it is. And I'm sure some of you also know it already, that you have the P. vivax, P. ovale, P. malaria, and of course, the almighty P. falciparum, and now P. knowlesi. Knowlesi. Knowlesi is spelled Knowlesi. Knowlesi. It used to be the malaria that affects monkeys. It has been known that that species of malaria also affects human beings. And in fact, in Southeast Asia, it is all Malaysia area, is it Malaysia? Yes, those areas. The commonest malaria species would be the malaria knowlesi. And like I keep on telling you, you are not being trained for practice in Ghana alone. You are being trained for the global scientific world. And therefore, you should know what is happening within the scientific technological diagnostics. So that is just by way of preliminary information. Now, so going back to the malaria parasite, some few highlights, like I've said. all of us have a fair idea about the Plasmodium as the parasite that will cause the malaria. And there's this common thing they normally ask the diplomats, that before malaria, the parasite was probably discovered, if discovered is a good word. If it's not a good word, just pardon me. But before malaria parasite was detected or discovered, malaria, the name malaria, the disease was there, and it was thought to be caused by, I just want somebody to give me an answer if you have, just by way of a startup, that before malaria was known to be caused by a parasite called Plasmodium. What was it thought to be the cause? Was it due to evil spirits? Was it due to what was supposed to be the cause of malaria disease? Who has an idea to share with us? I'm expecting an answer on the platform. Just in case somebody knows it. I'm giving you some 2 minutes to look for an answer. That before malaria was known to be caused by the Plasmodium, what was it known to be the cause? Now, look at the word malaria. Mal means bad. Okay, mal. When you say, I think those of you who are very good in English will know that the prefix mal, not mall as in shopping mall, malabsorption. Okay, malabsorption means bad absorption, like improper absorption. Okay, so mal is normally supposed to be a meaning for bad or something which is not good. Now, and then area. So malaria. And then the area is about air. Okay, I think somebody's giving you some answer. Fantastic. Nana Sabi is always making my day. That's good. So before malaria, the parasite was actually discovered or detected. It was thought to be caused by foul air, or for that matter, bad air. Okay, so it means that, in that time, they didn't know that it was caused by a parasite. They felt that when your environment is smelling bad, then you are likely. So it means that even in those times, people related malaria with an environment. Up to date, you know that it has nothing to do with environment. If you have stagnant waters and stuff like that, they breed mosquitoes, and then inadvertently you may get your malaria. So this is a very simple question they will normally ask of the, or they will, let's say, is it a trick or something? They will ask the diploma people, so take note. So the word malaria describes its origin, where it was thought that it was caused by foul or bad air. So that's just by the way. So it came to be known that the parasite Plasmodium will cause it. And all of us by now know that it has 2 cycles. One cycle in the mosquito, and then the other cycle in the human. Have to take note that people think that because the cycle is a human being, then it could be sexual. No. Rather, the cycle in the mosquito is rather a sexual cycle. Sexual. And then the cycle in the human or in the man is asexual. All right, so take note, sometimes it's very tricky, but it is one of the commonest questions they will ask, if not at all, at least the diploma people. And normally they wouldn't ask you that, or they wouldn't say that, what is the type of reproduction that occurs in the mosquito with respect to malaria. They won't do that. They will normally make a general lot of statements, and then they will ask that you find out which one is not true. Okay, so for example, if you have a situation where they say sexual reproduction and asexual reproduction takes place in the mosquito and then the man respectively, then you should be able to know which one is linking what. All right, so if they say respectively, it means that when they say the sexual first, and then they also said the mosquito and man, and then sexual and asexual, then it means that the sexual is going for mosquito, and then the asexual is going for the man. And asexual reproduction occurs in man. Take note of that, please. So, like I said, I'm just trying to highlight some of the points that you may have to refresh your minds on with respect to malaria. And there are certain terminologies like sporogony, those kind of terminologies. I don't know how they may frame questions about, but you should try to understand them. They are very simple. Gametogony means that it ends up producing gametes. Okay. When you say merogony, as far as the malaria is concerned, they are producing merozoites. So sporogony will end up producing sporozoites. Okay. Then schizogony. Schizogony will end up producing schizons. So then the question is, so if it's schizogony, where do you have schizons? You never have schizons in the mosquito. The mosquito cycle, you should know it very, very well. When the mosquito has taken a meal that contains the gametocytes, and you should know that the gametocytes, the mosquito should take up both the male and female. Okay, and the macro gametocyte, macro, the big one, macro is the big one, is the female. Normally, as far as parasites are concerned, it is the females that are usually big, and the males are normally small. So just take it as a fun, but a lot of times it is true. So the macro gametocyte, it is the female gametocyte. And then the micro, it is the smaller one, which is the male gametocytes. Micro, small. You can say that as for the females, they have big buttocks. So they will be big. And then, so they will be the macro gametocytes. So once the mosquito picks up the macro and then the micro gametocytes, they mature further to become gametes. Okay, the gametocyte is like immature. Okay, the immature cells. So when they become mature, they become gametes. So you have the macro gamete, which is still the female gametocyte, and then the microgamete, which is the male. So it depends on how they want to trick you, but you should know that. So you don't have the macro or the gametes in humans, because in humans you only have the gametocytes. Once they come into the mosquito, when the mosquito plays them, they will undergo further maturation and become the gametes. So that is how you should understand some of those things. So It depends on how somebody will want to trick you. But like I've always said over and over again, once you understand the dynamics of all these things, to me, you don't necessarily even need past questions, because as for the question, they can be twisted anytime, anyhow. But once you get the dynamics right, you will always get it correct. So I'm saying that when they ask you that the gametes, the macrogametes and microgametes, they only define the mosquito. And then it is because you have male and female. This is, and as far as the human in the humans, they are gametes, they are immature. Because they are immature, they could not have what do you call it? Let's say come together or fertilize, if that's the right way. Because over there they are immature. And so they get to the maturity stage in the mosquito. They form gametes. So that's why they are coming together. So they come together to form a zygote. The zygote will also form what we call the oocyst. The oocyst will become the ookinet, and then the ookinet will eventually give you the sporozoites. Okay, so this sporozoites is the one which is infective to man. Take note. It is the sporozoites which are infective to man. Okay, now as soon as they get into man, the sporozoites will immediately move into the liver. Once they move into the liver, they also undergo that kind of development, form schizons there. But you see that this primary development are outside the red cells. So initial development takes place within the liver, and they are outside the red cells. So we call them extra erythrocytic phase. Let me put it that way. Extra, outside the erythrocytic phase. So when you get malaria in the first place, it doesn't, you don't feel the symptoms, because the parasite will not be in the bloodstream. They will be in the liver. Now there's also a common question they ask. Now, once they are in the liver, what happens? They go through a cycle of development. That cycle of development takes place once. Please take note. The cycle of development of the parasites in the liver occurs once. So they go through that cycle to become together, to become the schizons, and then they will further get into the merozoites. Once this happens, it happens once, and then the merozoites come into the bloodstream to start the erythrocytic phase. Please, the only time, or okay, let me put it this way, the only species that retain some of the let's say the merozoites, which were supposed to have come into the bloodstream, then will be the P. vivax and the P. ovale. Take note. Anytime I say take note, I mean it. So once some of the parasites retain in the liver, they are not going to undergo another cycle. So that's why I'm saying that sometimes they ask the question, how many cycles of development that the parasites undergo in the liver? It goes only once. Okay, all the species, they go once, except that some species like the P. vivax and then the P. ovale will retain some of them. Once they retain some of them, they form what we call the hypnozoites. And you know, it is coming from I've forgotten this English word which say that which tend to be hypnotized. It's like it says sometimes somebody who can put something in your eye or something, and before you could say Jack, wherever he asks you to follow him, you follow the person. It's like you are hypnotized. So these are the type of thing that you are describing. The merozoites will become like hypnotized. So that's why they call them hypnozoites. They don't undergo any further development. They just hide in there. And sometimes after a week or even 2 weeks or even a month or even years, the individual has not been exposed to another virus, that individual will certainly develop malaria. Then the question is, how come that for all this while, I've not been bitten by malaria. Sorry, I've not been bitten by any mosquito, and now I'm also getting malaria. Then this will be traced to probably hypnosis, which is now coming back into the bloodstream. Into the bloodstream, they start the cycle again. But remember that it doesn't mean that a cycle is repeated in the liver. The life cycle or the cycle of development in the liver takes place once. So whether it is hypnosis or no hypnosis, even if they are hypnosis, the hypnosis don't go through another cycle. They are just into the bloodstream. I'm saying that the species that are able to undergo this hypnosis is the P. vivax and then the P. ovale. P. vivax and P. ovale. Now, however, it appears that the P. vivax is more prevalent. So if you have a situation where you combine the two, take all the two, where you have only the P. vivax alone, because of the hypnosis, it is the P. vivax that is always dominant. But the P. ovale also undergo now, because you have not been exposed to another mosquito bite, yet you are getting this thing, we call it relapse. So relapses will occur only in P. vivax and P. ovale. Please take note. Relapse, malaria relapses can occur only in P. vivax and P. ovale. We also take note, there's something called recrudescence. Recrudescence also appears to be like getting under malaria when you have not been exposed to any another mosquito bite. But it is different from relapse. Relapse is just a release of the hypnozoids into the bloodstream to restart the malaria. But if you have malaria and you have not been properly treated, please take note. Let's say you have some, especially in most places, the villages, give them anti-malaria to take for 3 days. They take 1 day, the following day they think that you're all right, okay, then they leave it. So in that case, you don't get total elimination of the parasites. So it's like some go dormant and then come back to life and then restart. That one is not from the hypnosis. That one is what we call recrudescence. The difference between recrudescence and relapse, even though they all appear to behave the same, because it's like somebody having. Okay, so then somebody's microphone on and it's disturbing. This is the information we have. Somebody's microphone is on. Can you please mute it? So this is, I'm taking you through this knowing that you already have gone through malaria several times in school or on your own. I'm just trying to highlight on areas that could come as questions. Okay, right. I'm saying that the difference between recrudescence and relapse is that relapses are coming from hypnozoids. And hypnozoids are those merozoids that fail to be released into the bloodstream from the liver. They are rather kept in the hepatocytes, the liver cells. And then at their own time, sometimes even after years, then that you think that you had malaria, you treated yourself, and then all of a sudden within a week you are getting malaria again. That is not due to hypnosis. That is due to improper, or let's say partial treatment. If you didn't treat yourself well, then the parasites will not have been eliminated, and then some few stubborn ones will come back and then restart the malaria. Okay, so that is the difference between recrudescence and relapse. Okay, all right, so the gentleman has apologized. No, it's not a gentleman, it's better, so it's a lady. Okay, he has apologized and you take it. Thank you, better, for the apology. So I want you to take note, because sometimes if you don't understand the principles, anytime they trick the question, then you find one thing. So relapse and recrudescence, of course, they will also give you like what do you call it? Like malaria, when you have no history of malaria or of mosquito bites, but one is coming from hypnozoids, and one is coming from the recrudescence. So if you look at this carefully, you see that technically recrudescence will be due to falciparum, because the falciparum, that's always a stubborn one. Okay, falciparum is always stubborn, and they also causes high parasitemia. They can cause what do you call it? About 20% or more of parasite load. So it means that because there are many, there could be many in the bloodstream, and if you don't take in adequate treatment, then some will still remain. So you definitely will see that recrudescence will be most likely coming from falciparum and not from the other ones. Okay, whilst the relapse is coming from this and that. I'm sure you also know about the story of P. vivax, why we don't have it commonly in our setting. P. vivax is known to have their receptors on Duffy blood group antigen. You know that there's a blood group called the Duffy, D-U-F-F-Y. Okay. And the short form, like blood group A, blood group B, blood group C, whatever. Duffy is represented by FY, even though the true spell is D-U-F-F-Y. But if you say FY, you are talking about the Duffy blood group. Now, it has been known that in our sub-region, West Africa, most of the blood group antigen Duffy is almost non-existent. So therefore, since the vivax, the receptors for attaching itself to the what do you call it, to the rest cell is absent on the rest cells of most West African inhabitants, then it will mean that if you have P. vivax, they will not be able to infect the rest cells, because the rest cells don't have the receptors which are on the Duffy. So it is also a well-known history that because Duffy antigen is always negative in our setting, then it's unlikely that P. vivax, malaria P. vivax, will be found in our distance. So those, if you want to do speciation, malaria speciation, and even you don't know, P. vivax should be out. If you have to do some, what do you call it? It's like autolota. Autolota, you straight away know that P. vivax is out. Okay, looking knowing that P. vivax is linked or has its receptor on Duffy, and Duffy, most of the people in West Africa have Duffy antigen negative. Okay, they lack the Duffy antigen. Then that is how this is. So that is that. You also have to know that let me. Sometimes they can also trick you. You know, the malaria parasite, both the what happens in the mosquito and what happens in this. Sometimes they want to find out whether you know exactly what is in the mosquito. So they can probably write something like which of these is not found in the mosquito. So then they talk about sporozoites, oocysts, ookinet, and then zygotes and so forth and so on. And all of it. So they can bring in schizons. Then straight out the way, you know that schizons will never be found in a mosquito. And therefore, that would be the odd answer. Similarly, they can list some of the stages that are likely to be found in the humans. And so you should know all those things. In the humans, of course, we've talked about the schizons. And then we've talked about the schizons breaking to give you the, what do you call it? The merozoites. The merozoites, please hold on for me. My battery is running low. I want to bring my charger. Sorry. Okay. Hello. All right. So I'm sorry, my laptop went off. I was struggling to get it back. So I'm now back. Can we continue?
Yeah, we can, Grandpa. Grandpa, please, I didn't get the explanation well for the Daffy. Like my line was, so I didn't really hear it well.
Please come again. Say I should go over what? The
Daffy, the
Daffy.
Daffy.
Okay.
Yeah, for our sub-region.
So thank you. Say we are only familiar with blood group A, blood group B, blood group O, and so forth and so on, resource groups. But there are several different blood group systems. Okay, and one of such other groups is called the Duffy blood group. Duffy spelled D-U-F-F-Y. Duffy, D-U-F-F-Y. And for this short form, it is usually written F-Y. F-Y, but the...
Nice, Kevin. Now in the power dane. Aha. So I'm mentioning King.
All right. I hope someone to be done. All right. So
Yeah.
No, I'm just making a mockery of a lady was saying, "Good empowering in car." Anyway, that's just by the way. So the Duffy is one of the blood groups, okay, and like familiar ones are the blood group A, blood group B, blood group O, the resource groups. There are a lot of other blood groups, and this one is called a Duffy. Duffy is written F-Y. The actual spelling is D-U-F-F-Y. Now you know that for every blood group, there's always genotypically, we have one from each of the parents. So it's Duffy A and Duffy B combined. So you're either Duffy A positive and Duffy B negative, or Duffy B negative, and so forth. So for most of West African inhabitants, it's Duffy A and B all negative. So what it means is that when you are tested for Duffy, you can never be positive. Now, you know that the parasite, the malaria parasite, before it can invade the red cell, it must be able to attach itself to a red cell before it gets into the red cell itself. Now, for the P virus, its receptor is found on the Duffy antigen. The receptor for it's like yes, it's like it uses the Duffy antigen as the crank-board or something before it jumps into the red cell inside. Now, since you and I in West Africa, studies have shown that Duffy A, Duffy B, and for that matter, Duffy groups are negative for us. Then it means that once even you are even exposed to the virus, P virus, the P virus will never be able to get into the red cell, because if you must get to the red cells to replicate it themselves there, and then they cause the clinical manifestations of malaria. Okay, but since it can only get into the red cell by attaching itself first and foremost on the Duffy antigen, and the Duffy antigen is absent, then it means that you will never be infected with the P virus. That's what I'm saying. You can read more about that. The Duffy and P virus. Okay, so it means that you are protected. Me and you, West Africa, we are protected against P. vivax malaria infection. That is in simple terms, that is what it is. Okay, very good. So we move on. So there's also something that usually will trick you, that if, let's say, you are doing you have a slide, you are working on it, and you have seen in the slide, you have seen dermatocytes, you have seen schizons, you have seen the trophozoites. It can never be P. falciparum. They can never be. You see, P. falciparum, what happens is that apart from the trophozoites, okay, all the other stages, like the gametocytes and then the gametocytes, excuse me, the schizons, and they normally they say they cause sequestration. So it means that they will find themselves in the internal organs, in the veins of internal organs, and therefore they become almost unavailable in the peripheral blood. Okay, so for that matter, it serves as a means of differentiating some of the malaria species. So if they tell you that, oh, in which of these species can we find all the stages in the bloodstream, malaria falciparum, plasmodium falciparum should be counted out. Okay, so that's also some of the tricks that can be used on states. Right. If you have an abnormal hemoglobin, you are almost always protected against malaria, of course. Even if you get malaria, you are not going to get its severe infection. And so if you have hemoglobin F, hemoglobin S, hemoglobin C, those hemoglobins other than, and even of course thalassemia, the parasites find it uncomfortable to survive in the red cells. Remember that the red cells harbor the parasites, and then they will develop in there, multiply to give you a lot of the merozoites. The merozoites, they will break the red cells and then reinfect under red cells. So within the red cells, they use up hemoglobin. Once they use up hemoglobin, the end product or the byproducts of the hemoglobin metabolism for malaria is called hemozoites. So when the red cells break, the malaria break the red cells, they release their byproducts, which is the hemozoid. So it is this one that causes the rigor in the malaria patient. Okay, and then so the merozoites will now reinfect new red cells, but the toxins, their waste, which was released, will continue to give you that kind of high fever, or a fever, not high fever. When you talk about high fever, it's a different thing. But to give you the fever. Okay. Now, so those are some of the dynamics. So it means that they will need a lot of hemoglobin. And you know that if you have, let's say, hemoglobin S, how much of hemoglobin are there in hemoglobin S? It's already anemic. So the parasites will not be able to develop full-blown within the sickle cell or the hemoglobin S red cell, and therefore they are not able to survive. Similarly, for hemoglobin C, you know hemoglobin C is characterized by target cells, where the whole central portion have no hemoglobin. Okay, so it means that they also have, they don't have the hemoglobin that will support the development of the malaria or the falciparum. And so they are, so in short, you can have questions that want to trick you to find out whether you know that the hemoglobinopathies, and for that matter, abnormal hemoglobin, provide some form of protection against malaria. And I'm sure that this is a known fact, and you should know that. All right. I've tried to explain the cause of the malaria fever, okay, where the red cells will break. When the red cells break, the end product of the hemoglobin, which are metabolized, which is the hemogen, will come into the bloodstream to give you this thing. Now, it goes in 3 stages. 3 stages. So also take note. The malaria, this kind of rigor or the fever, the fever which is characterized with this thing, I have 3 stages. We have the hot stage, the cold stage, and the sweating stage. This is well known by everyone, even those who are not even scientists. They know that when you have malaria, it has 3 stages. You have the cold stage as a awado. The next moment as a shoulder. In the next moment, you know you are sweating. That kind of febrile phenomenon. We call the malaria paroxysms. So those paroxysms of malaria fever occurs in 3 stages: the cold stage, the hot stage, and the sweating stage. These things are very common. And how often do they occur? Okay, how often do they occur? So you see that this is associated with the rate at which the parasites develop within the red cells and then break. So the development of the red cells, of the parasite in the red cells, leading to the breakup of the red cells, takes place within a certain period, and that appears to be very consistent. Almost all the species would do so in 48 hours. Okay, in 48 hours. And all of us know that normally 48 hours is supposed to be 2 days. But characteristically, we say that 48 hours is usually 3 days, a 3rd day. So we use the word tertian. Tertian got to do with 3. Okay, so but by way of hours, it is 48 hours. If you do cultures are technically 48 hours, but yet we say the cultures it takes 3 days. So this phenomenon of malaria, the fever associated with malaria, will take place almost every 48 hours. And the 48 hours is characteristically 3 days. And therefore, we use the word tertian. And so you can talk about malignant tertian malaria. Malignant tertian malaria is associated with P. falciparum. Why? When we talk about malignant, it means that it's deadly. Okay, it is deadly. And for the malaria species, the one which all of us know to be deadly, we can kill, have high mortality, is the falciparum. So it means that the malignant are associated with the falciparum. And then tertian, because every 3 days, that fever that we're talking about will occur. Okay. So when we talk about malignant tertian malaria, we are referring to P. falciparum infection. Now, of the malaria parasites, the one which has the longest febrile cycle, okay, like we are talking about, we said that technically all of them have, let's say, 48 hours, which is equivalent to 3 days. But malaria, you know, we have the malaria has the longest. Instead of 48 hours, it takes 72 hours. The malaria has the longest febrile duration. Okay, so when you have that, the 3 stages of cold, hot, sweat, it appears to occur today, then all of a sudden it will vanish. And then it will not come after 3 days, then it comes again. So for the 72 hours, by the calculation, it becomes 4 days. And 4 days appears to be a quarter. So we say that we call it quartile malaria. So that's the way to try to remember, because sometimes you get confused. This malignant tertiary malaria and this part-time malaria, what is it? So the quartile got to do with timing, okay? And the tertiary also got to do with timing. The tertiary is 3 days and quartile is 4 days, quarter, okay? Quarter. You know that when you have a quarter, it's 4. So you can use that as a mnemonic. And you know, mnemonic is something, anything that can help you to remember something. So for the quarter, it is quartile, and for that matter, it's 4 days. And then for the tertiary, it's 3, something like that. That is just to help you remember. So the malaria has the longest days, okay, of the cycle, and it constitutes the quartile malaria. I hope that will help you to remember it. And these are some of the, as far as I know, the way they try to set questions with respect to malaria. Let me see, I put some few points down. Let me see which other area you need to deal with. So I think technically these are the few points. Of course, you can read the whole malaria concept, the whole plasmodium, and you can read. But for purposes of preparing for exam, these are the key points that I think will help you. All right. So any question on the malaria discussion? Any question on the malaria discussion? All right. I assume that it is gone well. Just some few points also to note on parasitology. There are some parasites, you have to know them and know very well. Okay. I'm sure you know about the STHs. STHs are the soil transmitted herpes.
Every day when you come, you have to clean the rubber. You are the rubber, we know the man from them. One.
All right. So some of the common parasites which you should know and know well are the STHs, that's the soil transmitted herpes. That is the herpes that will normally will use the soil as a means of transmission. And of course, if you don't know at all, at least the hookworms, you know that hookworms transform itself into the filariform stage before it can be effective to man. Okay, so it is technically a cell-transmitted herpes. And then the Stranguladis too is about the same. And then, of course, Ascaris is also a cell-transmitted herpes. And Trachurus trachura, they are all cell-transmitted herpes. One thing that normally they will mix up with this is Enterobius vermicularis. Enterobius vermicularis is never, it's not one of the cell transmitted hermits. Just because once you scratch your anus, remember it causes a lot of itching at the anus, so you call it pruritus ani. Pruritus ani. Pruritus is itching. Ani, A-N-I, as in anus. So if, especially for the diploma level, they can ask you which of these parasites are known to cause pruritus ani, or there's a patient complains of pruritus ani, which of these parasites is likely to be the cause. So that would be Enterobius. Enterobius vermicularis. Sometimes they also confuse you. Enterobius vermicularis has an old name called Oxyrus. Oxyrus. So take note. Whenever you see Oxyrus or Oxyriosis, it is the same thing as Enterobius vermicularis infection. Good. So, but it is not one of the sweat transmitted herpes. Take note. Now, it is also not a parasite that can be detected in stool. It is also a very tricky question that comes up. For Enterobius vermicularis, you know, the eggs are laid at the anus during the night, and the parasite, the adult, will go back into the rectum area. And then you have the eggs have a flattened side, one side flat. And therefore, when you are